All right, today we're looking at inverse relations. The inverse of a relation S is written as S raised to the negative 1. So we're specifically just talking about a relation. In order to find the inverse of a relation, you just swap all of the x and y values. So you're literally just changing, if it's an x, it becomes a y. If it's a y value, it becomes an x value. How do we determine a one-to-one relationship / what is a one-to-one relationship? It means each x has exactly one unique y. This is telling us that no y values repeat themselves. So let's look at some examples of relations and inverse relations. So this first relation S is written as 1, negative 2 is the first value. So when we rewrite a relation, we're going to put that curly bracket and then parentheses. In order to make the inverse, you're physically just swapping the x and y values. So this first one is going to become negative 2, comma 1. The next one is going to become 4, comma 2. The third one is going to become negative 1, comma 3. And the last one is going to become negative 2, comma 4. All right. So all we did was we physically just changed x and y. Is S a function? Well, to determine if something is a function, we just look at the x's. Do any of the x's in S repeat themselves? We have 1, 2, 3, 4. So none of them repeat, so S is a function, yes. Is S to the negative 1 a function? So let's look at this. Do any of the x values repeat themselves in S, inverse S? In this case, it looks like it does, right? Negative 2 shows up twice, so the inverse of S is not a function. And then is S 1-to-1? So it means that each y value is unique, none repeat. In this case, we have a negative 2 in the first term and a negative 2 in the last term. So is S 1-to-1? It is not. Let's take a look at number 2. So if we're rewriting this, again, we just swap the x's and the y's. So this is going to be 5, 1. The next one will be 6, 1. The third one will be negative 4, 3. And then the last term would be 9, 4. Is S a function? Well, the 1's repeat in the first term, so no, this is not a function. Is the inverse of S a function? We have 5, 6, negative 4, and positive 9. So yes, the inverse is a function. All right, is S 1-to-1? Well, it has to be a function first in order for it to be 1-to-1. So S cannot be 1-to-1 in this case. All right, next one. Again, just swapping the x's and the y's. So we have 4, comma 2, 6, comma 3, 8, comma 4, and 10, comma 5. That's how you make an inverse. You literally just swap the x's and y's, that's all. This is for a relation like this. It's also going to be the same thing for our functions. If you see a graph of a function, you just swap the x's and y's, and that's how you graph the inverse. So is S a function? We have 2, 3, 4, and 5. So yes, it is a function. Is the inverse of S a function? We have 4, 6, 8, and 10. Yes, also a function. Is it 1-to-1? In this case, because both of them are functions, this tells us that it is 1-to-1, because all of the y values from the first one become the x values in the second one. So if we said none of the x values repeat in either the first relation or its inverse, then the relation is 1-to-1. All right, and you can go back through and look at the y's. We have 4, 6, 8, and 10. None of the y's repeat themselves. They're all unique. So therefore, also, it is 1-to-1. Recall the vertical line test is used to determine whether a relation is a function, given a graph. The horizontal line test is used to determine whether the inverse, sorry, I was blanking right there what that blank was, whether the inverse of a relation is a function. So it says both the relation and its inverse must be functions in order for it to be one-to-one, right? This is important. They have to be functions to be one-to-one. That's why I bolded it for you. So determine whether the relation shown represents a one-to-one function. All you do, vertical line test, so yes, function. Then we throw the horizontal line test, and it passes the horizontal line test, so yes, it's a function, and it's one. We can just write it quickly, right? We've written one-to-one before. One-to-one. So, passes both the vertical and the horizontal line test, means it's one-to-one. We take a look at this next one. So yes, we're a function. We pass the vertical line test, but then we try to draw a horizontal line test. So yes, function. No, one-to-one. Alrighty. Inverse function. So the inverse of a function, f of x, is written as f negative 1 of x. And that's how you write the inverse of f. To find the inverse of a function, you interchange x with f of x. Your second step is to rewrite f of x as f to the negative 1 of x, and then you just solve for f to the negative 1 of x, or inverse of x. So it looks just like this. We swap the f with the x. Those two change places. So we say x is equal to 5, and then we write it as the inverse. Inverse f of x. From here, we just need to solve for that, so we divide by 5 on both sides. You get x over 5 is equal to the inverse f of x. All right? And that's all. That's all there is to it. So for number 6, let's do that same exact thing, right? Swap the f and swap the x. That's going to give us x is equal to the inverse of f minus 7. We add that 7 to the other side. You get x plus 7 is equal to the inverse f of x. All right. Next one. Right here, we're just swapping the f and the x. So it's x is equal to the inverse f of x minus 8 divided by 3. So first we need to multiply 3 by both sides to get 3x is equal to the inverse f of x minus 8. And then you just add 8 to both sides to get f inverse of x is equal to 3x plus 8. If you're doing okay in this section, guys, it just completely makes sense to you, feel free to work ahead a little bit. Next up, we have switching f and x again. So x equals negative 2/5 f inverse of x plus 1. And then it's just solving for that inverse. So x minus 1 equals negative 2/5 f inverse of x. Multiply by the reciprocal, so 5 over 2, negative, because we want the negatives to cancel, the 5s to cancel, and the 2s to cancel. So we multiply this whole thing by negative 5/2. And so then our inverse function is negative 5/2. And I'm okay if you keep it like this. X minus 1 equals f inverse of x. No need to distribute that negative 5/2 into that parentheses. We're good, just as it is. Number 10, let's swap again. So we're going this is x now. X is equal to the inverse f of x squared minus 9. Remember, don't forget those parentheses around what you're putting in there, guys. Super important. All right, so if we're taking a look at this next one, we add 9 to both sides. You get x plus 9 is equal to f inverse of x squared. And then we're going to square root both sides. All right, when you square root both sides, we put that square root in there, so you have to put plus or minus, and then it's the square root of x plus 9 is equal to f inverse of x. Can't forget that plus or minus there, guys. Super important. Okay? So, what does this one look like? Let's talk about it. The first function, the original function, -9, right, looks like quadratic. The next function is the square root of x plus 9. So the next function has shifted to the left, so we're over here. And then this function goes up like this, because that would be positive square root of x plus 9. The negative square root of x plus 9 looks like this, right? So it's just the negative version. So what happened here? Well, if you look, we just rotated the graph 90 degrees, right? Okay. Last one here. Swap the x and the f of x, so x equals f inverse of x plus 4 cubed minus 6. So that's x plus 6 is equal to f inverse of x plus 4 cubed. Raise each side to the 1/3 power. So that's x plus 6 to the 1/3 equals f inverse of x plus 4. We subtract that 4 to the other side, so it becomes x plus 6 to the 1/3 minus 4 is equal to f inverse of x. All right? And that's all you're doing to find your inverse functions. You are literally just swapping your x's and your y's, just like we did in the relation, right? We swapped x's with y's, and then we just had to then find the y's. So, two functions, f and g, are inverse functions if and only if, when we plug g into f, you get x, and when you plug f into g, you also get x. So our composition of functions is coming back right here. You plug the g into the f, you should get x, and when you do that same operation but reversed, when you plug f into g, you also get x. So let's take a look at what an example of that looks like. So it's saying f of x is equal to x squared plus 8, and g of x is equal to the square root of x minus 8. So we're going to plug f of g of x. So we're plugging the g into the f. So that's going to give us, the square root of x minus 8 squared plus 8. That would be literally taking this equation, plugging it in for that x. Square and the square root cancel, so you get x minus 8 plus 8. So then you just get x. All right? We also need to make sure that the other one works out, so g of f of x. So then that's saying the square root of x squared plus 8, then minus 8. So these parentheses are not doing anything here, so we just say the square root of x squared plus 8 minus 8. So the plus 8 and minus 8 cancel. You get the square root of x squared, which gives you x. So because both of these came out to be just x, they are inverses. Let's take a look at the next example. So we go f of g of x, and then you're going to plug g, this equation, into the x. So -4, that's x over 4 minus 5 plus 5. So that's going to lead us to, we distribute that -4, so that's negative x plus 20 plus 5. So that gives us negative x plus 25. Well, that is not just x, so these things are not inverses. Okay. Moving on to the last page, talking about graphing our inverses. So, given triangle ABC is formed by the points in this relation, -1, 6, -7, 2, and -5, -3. What is the inverse of this relation? So remember, the inverse, just swap the x's and the y's. So 6, -1 is that first point. And then let's graph it. So we go 1, 2, 3, 4, 5, 6 to the right, and then down 1. Puts us right here. The next point is 2, negative 7. So we go 2 to the right, and then we go down 7. 1, 2, 3, 4, 5, 6, 7. And then we go negative 3, negative 5 for that last point. So negative 3, 1, 2, 3. Negative 5, 1, 2, 3, 4, 5. All right. So we graph this. All right. What does it say we notice about the graph here? Okay. Specifically, this graph, our inverse function, is literally just a reflection over the line y equals x. So we're physically just taking this graph and we're flipping it over the line y equals x. So it's a reflection across y equals x. And that's a super important thing to understand when it comes to looking at inverse relations. So the directions here say find the inverse of each function, then graph both functions and verify the inverse relationship of the graph. Sorry. So we go here, we just swap x and y, that's how we're going to find the inverse. So x equals 2 f inverse of x plus 8. We subtract that 8 first. X minus 8 is equal to 2 f inverse of x. Divide by 2. On the other side, it's easiest to just break up the 2's and divide the entire thing by 2. So that's 1/2 x minus 4 is equal to f inverse of x. Okay? So you take a look at this. Let's graph the original function. We'll graph that in the purplish blue here. So it's positive 8. 1, 2, 3, 4, 5, 6, 7, 8. We're going down to, or up 2 to the right one, sorry. Or down 2 to the left one, depending on how you look at that slope. So then we're going down 2 to the left one. Let's see if we can graph this well. Looks pretty good. The other graph is negative 4 is going to be the y-intercept, 1, 2, 3, 4. And then it's up 1 to the right 2, or down 1 to the left 2. So then we can graph this function. It's going like this through this graph. All right, how do we verify that they are inverses of each other? Well, let's draw in the line y equals x. So literally just this line that's going through the diagonal of this graph, right here. And then we just need to verify that it's a reflection onto itself. How do we do that? So if we look, we just need to see how far one point is away horizontally. So let's just take a look at this point. It's 1, 2, 3, 4 away horizontally. So then to reflect, if it goes straight down 4 and hits that point, it's going to be a reflection. So 1, 2, 3, 4. We hit that point on the graph, right? So then this, in fact, is a reflection across the line y equals x. Okay. If you're feeling pretty good and confident, feel free to just start the homework. If you need 2 more graphing examples, I'm going to go through them now. So we flip the x and y. F inverse of x minus 1. You add the 1 to the other side. You get x plus 1 is equal to the 1/3 f inverse of x. Multiply both sides by 3. All right, probably easy to distribute that 3 into here. So it's 3x plus 3 is equal to f inverse of x. So we're going positive 3. 1, 2, 3 puts us here. And then it's going up 3 to the right 1. So there's our graph. Then we're going to graph it. Looks like this. Goes up like that. Okay, the original function, I'll graph it in that light blue again, is negative 1, and then it's going up 1 to the right 3. So here's this graph. Draw in the line y equals x, because we need to verify that this is good. So we'll just take this point, 1, 2, 3 from the line, 1, 2, 3 down. Yep, looks good. All right. Last but not least here, we have f of x equals x squared minus 4. So that's negative 4. 1, 2, 3, 4. All right. So these are actually the most basic functions to graph here. The only thing is that this negative 4 is the vertex. It's the y value of the vertex. X is just 0 here. So you go right 1, up 1, left 1, up 1. When you plug in 2, you would get out 4. So you go to the right 2, up 4. 1, 2, 3, 4. Left 2, up 4. 1, 2, 3, 4. Puts us here. So then our function looks like this. Hold on. Draw this better. All right, there's our function. Let's find the inverse function now. So that's x equals f inverse of x squared minus 4. So that's x plus 4 equals f inverse of x squared. Square root both sides. Remember, you have to add plus or minus because you square rooted both sides. So plus minus square root x plus 4 equals f inverse of x. What does this graph look like? So it's shifted to the left. It's literally just the square root function shifted to the left 4. So 1, 2, 3, 4 puts us right here. And then your parent function for the square root of x is literally just the square root of x. So we build a table. If you go 1 to the right, what do you get out when you plug that into the square root? You get 1. So 1 up 1. The next easiest value to plug into the square root is 4. When you plug in 4, you get up 2. 1, 2, 3, 4, up 2. And that's good, right? So there's the top portion of this function. We also have negative square root of x, right? So that's literally just the flipped version. So negative 1, negative 2, and then we graph that. And then let's graph in y equals x to make sure that we have correctly graphed the inverse function here. Let's take a look at a point. So if we graph this, we go to the right. What color am I? Yeah, that's a good color. So this point right here, this is the inverse function. So if we go down to the graph is right there. Then that means if we go 90 degrees, we should hit the other function. 1, 2, 90 degrees. All right. We hit here and here, which means yes, that is a reflection across the line y equals x. I know it's tough to see, but I promise you that's the way you check. You could do that with any point, right? So if we go horizontal to the y equals x line, 1, 2, 3, 4 from the original graph vertex, we go up 4, 1, 2, 3, 4, and we hit that. Okay, so we are in fact a reflection along the line y equals x. You can also see that, right, as I talked about it earlier, it's just a 90-degree rotation of the function. All right. As always, let me know if you guys have any messages in Canvas. I would love to help and answer anything that you have. Have a great day.